This is the Earth Science Classroom. In this video we're looking at plate tectonics and we're looking at plate boundaries, and this video is going to focus on the transform plate boundary. Now this is different to the previous boundaries we've covered on this channel, and looking at how these two or more plates, which creates a plate boundary, is going to move relative to each other and create different features on and under the Earth's surface. So as with other boundaries, we have the same layers, the crust and lithosphere, which creates the plate or the lithospheric plate, and below it we have the asthenosphere, which is our plastic, our flow, our hot but also dense rock layer, which extends down to about 610 kilometers from the Moho, and this could be either oceanic or continental plates. And we have our convection currents in the asthenosphere. So this plate boundary is the dividing point between the two plates, and this plate boundary is kind of unique because it does not involve any kind of constructive plate margin where the plates are being formed, which is divergent with the lava coming up at the rift or the ridge and creating new crust, which then spreads away, which is seafloor spreading under the ocean, nor is it destructive, which includes either mountain building and orogeny or with subduction and melting to form volcanoes. This is a point of reference on the Earth's surface where the plates are moving past each other, they slide past each other and create a lot of friction and movement, and of course earthquakes as a major feature or outcome of this plate boundary, which is earthquakes. But it is the motion and the speed of motion and direction of motion of the two plates which is very important to consider. So the variables in this boundary are the plate's composition, the plate's density, the types of plates, oceanic, continental, the rate or speed of motion, and the direction of motion can impact the amount of friction that is created, the energy, and result in earthquakes if and where they occur along these boundaries or these fault lines. And the classic example for this transform plate boundary is going to be the San Andreas Fault line or fault system, which is located mostly in California in North America in the States, and involves both the Pacific oceanic plate and the North American continental plate sliding past each other at different angles and speeds. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and maybe hit the like button. If you like more on this content, please check out my channel, which has all these videos on Earth science.